The purpose of this demonstration is to show the implementation of static methods. As you read in Chapter 9, a second look at classes and objects, the overall concept says that a static class member belongs to the class, not objects instantiated from the class. So specifically, when a class contains a static method, it is not necessary for an instance of the class to be created in order to execute the method. So, different than what we've done in our previous exercise, in order to refer to a static method, you can simply use a direct reference to the class. In this example, the purpose of this program is to allow the user to enter a distance in meters. The program will then present a menu of options for converting meters to various other measures of distance. So the program will convert the distance to kilometers, inches, or feet, depending on the user's selection. So what I've provided is partial code, just to get us on down the way just a bit. I do want to do a little bit of review as we continue with the demonstration and just hit some of the highlights as we go through the demo program. As you'll remember, if you're using console input, the first thing that you need to do is to import the scanner class, since it is not a part of the standard Java library. Then within the main method, the first thing that we have is the declaration of our local variables, two integer values, one for meters and one for the user's choice for the conversion. We then have the creation of a scanner object called keyboard, and remember, there's nothing special about the name keyboard. That's a user-defined name. We're combining the scanner object with the in object of the system class. This is referring to the standard input device, which we're all familiar with is the keyboard. Then we simply have a prompt to the user to enter the distance in meters. We capture the user's response using the nextInt method of the scanner class and assign that to the meters variable. As we scroll down, the next portion of the code that we encounter is a looping mechanism to validate the value of meters. In this case, if meters is less than 0, then we want to keep the user in this loop until they enter a correct value. We also have a do-while loop beginning at this point in our program for controlling the menu. And you see what the user will encounter is this particular menu. They are then prompted for their choice. Then we validate their choice using an if statement. And as you'll remember, the double ampersand is the AND operator. So in this case, as long as choice is greater than or equal to 1 and choice is less than or equal to 3, then we'll enter into the switch statement. Within the switch, we have 3 cases, each representing a conversion option. And you'll notice here we have several comment statements but no accompanying code. So this is where we'll complete this portion of the demo program. Before we're able to do that, however, we first need to build the conversion class. So as you'll remember from previous assignments, in order to add a second file, in this case a class file, we're going to select our ConversionProgram Demo. We'll select New from the menu. We want to select a new Java class. We will name it Conversion, and remember the naming convention is class names have an uppercase first character. We'll leave the default values and simply click Finish. As you'll also remember from previous projects, the class header is already provided for us, and so we're now ready to enter the appropriate code. Now, remember the concept behind a static method. It is not related to a specific instance of the class, and when I say instance, I'm referring to an object. In that case, in this particular scenario, that means we will not have private fields, nor will we have constructors, because we're not actually creating an object from this class. So the first method that we want to create, and I'm going to include comments for self-documentation, is the show kilometers method. Now, since these methods will need to be accessed by other portions of our program, each method will have a public access specifier, and as we know, in order to create static methods, we use the static keyword. We then provide the return data type, and since we're working with floating point values, I've chosen to use a double return data type, the name of the method, and then I need to specify what is being received by this method in the parameter list. If I go back to my demo program and I scroll to the top of the page, we'll notice that we declared meters as an integer value. Thus, the value that's being received by the show kilometers method will also need to be an integer. This is representing a parameter variable, which means that this variable's scope is within the method in which it is contained. After completing the method header, then, we need to simply write the method body. So, within this body, we're simply going to return the value of a calculation, which takes the value of m, which is representing meters, and multiplies it by the appropriate conversion value, in this case 0.001. And we have our closing brace for the show kilometers method. We will also need to create an appropriate method for the conversion to inches. So again, it is public, it is a static method, it will again return a double data type. The method name will be show inches, and this method too will receive a value representing meters. Once again, we'll simply return a calculation that takes the value of meters times the conversion value, which is 3937, and end it with a terminating semicolon. The final static method, again, is public, has a double return data type value for returning feet, and again it returns the value of, receives the value of meters. And we're going to return the result of the calculation of meters times the conversion value 3.281 and the terminating semicolon. And this completes the creation of the conversion class. When we return to our demo program, because each of these methods receives the same value, in this case meters, then it's appropriate to have a single input statement outside of the looping mechanism. Now, this is different from what you'll encounter in exercise or assignment 9.1, because to calculate the area of the various elements, those have different values. So what you'll need to think about is, where is the most appropriate place for placing your input statements. Now, if we navigate down to our switch statement, now we're ready to issue the method calls and pass the appropriate argument to each of our methods. Now, for the sake of brevity, we'll use a simple output statement. So our system class, using the out object, and I'll use the print line method, and this will be the conversion for kilometers. Within the print line parameter list, then I will concatenate the method call. Remember, the concept of a static method is that you do not have to create an object of the class. You can simply call that method directly using the class name. So the class name is conversion. We want to select show kilometers, and we're going to pass the value of meters. Then we can simply terminate the statement with a semicolon. The same will be true for calling the show inches method. So we'll use a simple output statement. This will be for inches. We will then concatenate the method call, and again preceded by the class name. This will be show inches, and the value that's being passed is the value of meters, and our terminating semicolon. We're then ready for our final method call. So our output statement for feet, again we're going to concatenate the method call, which begins with the class name. We're going to select show feet, and it's going to pass the value of meters. Now, once we've completed our demo program, we've also completed our conversion program. Then we're ready to execute and examine our results. So the user is prompted for the distance in meters, let's say 10. Then they're given the options for the conversions. So we can first convert to kilometers. We can then convert to inches. And finally, we can convert to feet. And just to test our program to make sure everything is working correctly, let's put in an invalid option. It should tell us, hey, you need to try again, and then pressing 4 will stop our program and tell us goodbye. And this concludes the demonstration.